Welcome to the Neuromodulation Podcast, presented to you by the International Neuromodulation Society. Dive into the forefront of today's emerging neuromodulation techniques, insights, and ethical and clinical applications. Subscribe now to join the multidisciplinary collaboration of medical care providers, scientists, and engineers who are part of the global conversation that's shaping the future of healthcare. Welcome to the Biostatistics Articles live reading series, presented by the International Neuromodulation Society and developed in collaboration with the Newcastle Cognition Lab at the University of Newcastle. I'm your host, Mandy Soleil, and it's a pleasure to have you here. We're pleased to offer this ongoing series of short articles explaining how to critically apprise clinically relevant literature to evaluate evidence and inform practice. The entire series of articles is available on our website at www.neuromodulation.com/biostatistics-articles, and a direct link to this article is available in the episode show notes. We've translated each article to a live episode on the Neuromodulation podcast to bring versatility and ease to your statistics learning journey. Each primer features a single topic and an example within the context of clinical neuromodulation research and practice. Upon reading and/or listening to these articles, learners will be able to understand statistical methods, their interpretation and their limitations, identify cognitive biases to avoid inadvertently misinterpreting evidence, and interpret data for a deeper understanding of clinical research to inform clinical practice. And now, I present to you Professor Konstantin Slavin, head of the Stereotactic and Functional Neurosurgery section at the University of Illinois Chicago, or UIC, and president-elect of the INS. His term as president begins September 1st, 2024. Thank you for tuning in.
The next installment of the Biostatistic articles for International Neuromodulation Society deals with types of data and the appropriate tests for them. It's written by Alexander Thorpe, Quentin Gronau, and Garston Liang. The caveat is that the data can be broadly separated into categorical and numerical data. Categorical data can be further separated into ordinal and nominal data, as illustrated in Figure 1. And the third caveat is that the appropriate statistical test depends on which combination of data types are tested. Part 1. Data types. When designing a study, it is important to consider the type of data you will collect, as this will also influence how you analyze your data. Below, we will discuss the different types of data. These definitions are true for both independent and dependent variables, and it is the combination of data types that determine which statistical tests are appropriate. Data can be broadly separated into two categories: numerical, where the data point can be represented as some kind of number or value with mathematical properties, and categorical, which is any other kind of data. We will also present examples of each data type that are relevant to neuromodulation literature. Part 2. Numerical data. When working with quantitative research methods, numerical data is the most common data type. It is also very common to work with numerical dependent variables, as we tend to measure outcomes with numerical scales. Numerical data is often further separated into two subcategories: discrete or interval, where data points can only take certain values, and continuous, where data can take any numerical value. Another subcategory, ratio, refers to data where 0 is the lowest possible value. For example, temperature is not expressed in ratio form because values below 0 can exist, but body weight is expressed in ratio form because it is impossible to weigh less than 0 kilogram. Despite these different subcategories and labels, all numerical data can be analyzed using the same statistical methods, so there is no need to consider them when choosing an appropriate test. Part 3. Categorical data. Categorical data, also known as qualitative data, refers to any data type that can be split into meaningful groups, but is not necessarily represented with numerical values. They are still present in quantitative research. In grouping variables, for example, can be category. Categorical data can be separated into ordinal data, where the categories have an inherent order, and nominal data, where the categories have not set order. Part 3.1 Ordinal Data. Ordinal data refers to data whose categories can be arranged in some kind of order. An example of this would be age groupings. Participants in a study of chronic pain could be categorized as young, adolescent, young adult, middle-aged, and elderly. These groups could be ordered such that participants in one group are older than the preceding group and younger than the succeeding group. This may be meaningful for a study's aims. If the study is examining the relationship between age group and incidence of chronic pain, the researchers may expect the incidence of chronic pain to increase from one group to the next. Part 3.2 Nominal Data. Nominal data cannot be grouped in the same way as ordinal data. Classifiers such as sex or experimental group membership are nominal, and there is no inherent order to male, female, or experimental control. These groups can be compared, but no relationship between the group membership and any dependent variable could be inferred just by ordering of the groups. A special case of nominal data is binary data, where data points belong to one of the two mutually exclusive groups and can be represented only as 0 or 1. The data is not numerical, and the numbers are used only to signify some property. One could just easily use true and false or yes and no. For example, data indicating whether or not participants meaningfully improved after treatment could be represented by binary values, so that 1 equals improved and 0 equals did not improve. This data type can be analyzed in ways other than nominal data cannot. Part 4. Appropriate tests. How do you know which statistical test to use? It all depends on the combination of data types of your independent variables, or the variables being manipulated, and dependent variables, or variables that measure an outcome. Figure 2 provides a brief guide to which test is appropriate based on data types. For more detailed guides, see the further reading section below. So the Figure 1 shows a dichotomy of data into categorical and numerical, and further dichotomy of categorical data into ordinal and nominal. The examples are such that ordinal categorical data would be an age group, young, middle age, and so forth. The nominal categorical data is the sex, male versus female. The numerical data, on the other hand, will be something like body weight, with an example being 75 kilograms. In terms of the appropriate tests for each combination, they are listed in Figure 2. All outcome variable types are classified into categorical and numerical, and the categorical can be measured either by logistic regression or chi-squared. The numerical data can be then divided into manipulated variable type, and that could be either categorical or numerical or mixed. Numerical or mixed will be measured with regression. Categorical will be further divided into number of manipulated variables. If it's more than one, the test of choice is ANOVA, or analysis of variations. If it's 1, then the level of manipulated variables can be either 2 or more than 2. For 2 levels, the best choice of testing is t-test. For more than 2, the best choice is once again ANOVA, which is analysis of variables. Further reading. Below are some open source resources that go into more detail about different data types and how to choose appropriate tests for them. The first one is by Swinskow from 1997. It is a book, Statistics at Square One. The second one is by Keba-Lepile in 2022, an article in South African Journal of Anesthesia and Analgesia. The third one is by Nayak and Hazra, published in Indian Journal of Ophthalmology in 2011. Thank you.